So let's take a look at some conversions with molecules. So let's take a look at this problem. It says how many grams of lithium in 5.92 times 10 to the 22nd atoms of lithium. Now, to relate atoms and grams, etc., you need to go through moles. And one thing is, whenever I say a mole of something, so 1 mole of anything is equal to Avogadro's number. So I'm going to say 1 mole of lithium is 6.02 times 10 to the 22nd. Couple of things with that. That Avogadro's number is 6.02 times 10 to the 23rd. It can be atoms, it can be molecules, it can be formula units. It just depends. But again, always 1 mole of something is always equal to Avogadro's number. In this case, as we're talking about just lithium, we're going to say atoms of lithium. So that's a crucial conversion. 1 mole of lithium is 6.02 times 10 to the 23rd atoms of lithium. Now, we need to get to grams eventually. Remember, 1 mole of anything is equal to the molar mass of that element or compound in terms of grams. So in this case, I'll look it up. Again, that's from the periodic table. To do this problem, we want to write down what's given. In this case, what's given is always the one in the original problem. It's 5.92 times 10 to the 22nd atoms of lithium. Eventually, we need to get to grams. You can do this a couple of different ways. Let's kind of go through moles. We'll say that, okay, Avogadro's number is equal to 1 mole of lithium. My atoms are canceling out, so I want to go from moles, let me make sure it's moles, to grams. Again, I use the molar mass of lithium. When you work this out, a couple of things. This is a good problem to do. Make sure you get your calculator and work this out because you got to use scientific notation like we did before. So again, you got to use the EE key to the 22nd for this case, EE to the 23rd in this case right here. So again, make sure you plug that in. You should end up, I think I worked it out, 0.683 grams of lithium. Let's continue with this. In this case, we said how many formula units. So again, in terms of terminology, whenever we talk about ionic compounds, they use formula units. So formula units because this is ionic. If it's a covalent compound, you use molecules. So covalent. You use molecules. So, and again, it's all going to be the same because 1 mole of something is equal to Avogadro's number. So in this case right here, I got to relate moles to formula units. So 1 mole of sodium oxide. Again, remember, 1 mole with Avogadro's. That's all you have to know. And that's equal to 6.02 times 10 to the 23rd formula units of sodium oxide. So again, we want to go from moles to formula units. So 1 mole, always Avogadro's number. We write down what's given. Formula units on top, moles on the bottom. If you work that out, and I think I'm going to get 3.66 times 10 to the 23rd formula units of sodium hydroxide. Again, the only difference between this one and the last problem is that I just call it formula units rather than atoms. This kind of finished this one out. This one's going to be slightly different. We'll say how many oxygen atoms in 3.5 moles of sulfur dioxide. So a couple of things. When I say 1 mole of sulfur dioxide, what that consists of is 1 mole of sulfur, because again, the subscript turns to be 1, and 2 moles of oxygen make up that covalent compound. So that's equal to 1 mole of sulfur. And again, the reason we know that because of that 2 right here. So 1 mole of sulfur dioxide is equal to 2 moles of oxygen. 1 mole of sulfur dioxide is equal to 1 mole of sulfur. So again, you have that ratio that makes it up. We're going to use that. So we write down what's given. .5 moles sulfur dioxide. Well, 1 mole of this is equal to 2 moles of oxygen. And then I need to get to atoms of oxygen. So this is my end game here. 1 mole is always equal to Avogadro's number. So 1 mole of oxygen . So when you do that, going to end up with 4.2 times 10 to the 24th atoms of oxygen.